find extrema on a closed interval, we have to check for both of the following. We have to check for relative extrema and endpoint extrema. Now I want to emphasize this is finding the absolute extrema on a closed interval. So this is not finding relative extrema. So the guidelines for finding the absolute extrema on a closed interval, we want to find the critical numbers of f in the open interval from a to b. We're going to evaluate f at each of those critical numbers. We're going to evaluate f at each of the endpoints, so that would be a and b. And then we're going to make a list of the y values. The least of them will be the minimum, and the greatest will be the maximum. So let's take a look at an example. I want to find the absolute extrema of f of x equals 3x to the fourth minus 4x cubed on the interval from -1 to 2. So step 1, we're going to find our critical numbers. And remember from the last video, the way we do that is we find the derivative. So that would be 12x cubed minus 12x squared. And we check where this doesn't exist or is equal to 0. So this is a polynomial. It exists everywhere, but it could equal 0. So we would solve that by factoring out the 12x squared. We're left with x minus 1. So I get x equals 0 or x equals 1 as my critical numbers. So step 2, I'm going to plug my critical numbers into f of x and find out what the y values are. Now notice I'm plugging them back into the original function. If I plugged them into f prime of x, I would get 0. We want to figure out what the y value is at that point. So f of 0 would be 3 times 0 to the fourth power minus 4 times 0 cubed, which is 0. F of 1 would be 3 times 1 to the fourth power minus 4 times 1 cubed, which is 3 minus 4, which is -1. So now that we've found the two critical values, we're going to find the endpoints. So for step 3, we're going to plug the endpoints into f of x. So the endpoints are -1 and 2, so f of -1 would be 3 times -1 to the fourth minus 4 times -1 cubed, which is going to be 3 minus -4, or 7. And f of 2 would be 3 times 2 to the fourth minus 4 times 2 cubed, which is going to be equal to 16. So when you look at the y values, we've got 4 of them, 0, -1, 7, and 16. You can see that 16 is the max and -1 is the min. So for step 4, we're just going to evaluate. We have an absolute maximum at the point 216, and we have an absolute minimum at the point 1, -1. So those are my answers for this problem. So again, we're going to find the absolute extrema of f of x equals 3 minus x on the interval from -3 to 3. So for step 1, we're going to find our critical numbers. So I need f prime of x, which would be -1 in this case. Now this exists everywhere, so we don't have any critical numbers from where it doesn't exist. But also f prime of x cannot be equal to 0. So that means there's no critical numbers that we need to plug in. So step 2, no critical numbers. Step 3, we do want to evaluate the endpoints. So f of 3, or f of -3, would be 3 minus -3, which is 6. And f of 3 would be 3 minus 3, which is 0. So this one has to be the max, and this one has to be the min. So for step 4, we just have an absolute maximum at the point -3, 6, and an absolute minimum at the point 3, 0. Now if you were to graph something like this, you could see it pretty clearly. So if I had, this is a straight line, the y-intercept is going to be at 3, and then it's going to go down 1/1 with a slope of -1, go up to the 6 here, and you can see what that looks like. and you can clearly see, and just pretend my line is straight here, you can clearly see the absolute maximum here at 6 and the absolute minimum here at 0. So sometimes you can visualize these a little bit better by graphing them, but this is the process to go through and find all of them. So another example here, we're going to start by finding the critical numbers. So this would be 3x squared minus 3x, if you multiply 3 halves by 2. And again, this exists everywhere, so we're just going to set it equal to 0. So 3x times x minus 1. So we get x equals 0 or 1 are the critical numbers. So step 2, we're going to plug those in. F of 0 would be 0 cubed minus 3 halves times 0 squared, so that's 0. F of 1 would be 1 cubed minus 3 halves times 1 squared, so that's 1 minus 3 halves, or negative 1 half. That was step 2, yeah, sorry, step 2. And then step 3, we're going to plug in the endpoint, so f of negative 1 would be negative 1 cubed minus 3 halves times negative 1 squared, so that's negative 1 minus 3 halves, or negative 5 halves. And then f of 2 would be 2 cubed minus 3 halves times 2 squared, so that's going to end up being 8 minus 6, or 2. So when you compare these numbers, you can see that you have a minimum here and you have a maximum here. So for step 4, we have an absolute maximum at the point 2, 2, and we have an absolute minimum at the point negative 1, negative 5 halves. So in this case, both maximum and minimum are in point extrema. Kind of a special example, we've got, you notice you've got an absolute value here, and remember the absolute value of x is defined as x if x is greater than or equal to 0, and negative x if x is less than 0. So if I were to take the absolute value of t minus 3, that would be t minus 3 if t minus 3 is greater than or equal to 0, or negative t minus 3 if t minus 3 is less than 0. So if I were taking 3 minus that, I could just plug that same 3 minus in front of that. So when I simplify it, I end up getting 6 minus t, and t minus 3 greater than or equal to 0 is the same as t greater than or equal to 3. And on the bottom, I just get t if t is less than 3. So that is what my function actually is. This is f of t. So I'm going to come over here and I'm going to find the derivative. So f prime of t would be equal to negative 1 if t is greater than or equal to 3, and 1 if t is less than 3. Okay, so one thing that's important to note here is that as t approaches 3, f prime of 3 is defined technically as a limit. So in this case, f of 3 exists, but f prime of 3 does not exist, because if you were to look at the graph of it at 3, you would have on the right hand side, you would have a negative 1, so it would look like this, and on the right hand side you would have a positive 1, so it would end up looking like this. So technically f prime of 3 does not exist. So t equals 3 is a critical number, and in fact it's the only critical number because there's no way that this will be equal to 0. So t equals 3 is a critical number. So we do need to check that. So for step 2, I'm going to find f of 3, which would be 3 minus the absolute value of 3 minus 3, or 3 minus 0, or 3. And then for step 3, I'm going to check the endpoint. So f of negative 1 would be 3 minus the absolute value of negative 1 minus 3, which is 3 minus the absolute value of negative 4, which is 3 minus 4, or negative 1. And f of 5 would be 3 minus the absolute value of 5 minus 3, which is 3 minus the absolute value of 2, or 3 minus 2, or 1. So we can see here that the 3 is the max and the negative 1 is the min. So for step 4, we have the absolute max at the ordered pair 3, 3, and we have the absolute minimum at the ordered pair negative 1, negative 1. We can do the same process with trigonometric functions also. So step 1, I'm going to find the derivative. So y prime is going to be 3 times negative sine of x, or negative 3 sine of x. So again, this derivative exists everywhere, so no problem there. We do want to see where it's equal to 0. So negative 3 sine of x equals 0 basically means that sine of x equals 0. So if you're looking at a unit circle, the only places from 0 to 2 pi where sine of x equals 0 are where x is equal to 0, pi, or 2 pi. So it just so happens that 2 of those points happen to be the endpoints. So steps 2 and 3 are basically the same. We'll find f of 0, which is negative 3 sine of 0. I'm sorry, we're going to find f of 0, which is 3 cosine of 0. So cosine of 0 happens to be 1, so this is 3. We're going to find f of pi, where this is going to be 3 cosine of pi, which is 3 times negative 1, which is negative 3. And we're going to find f of 2 pi, which is 3 cosine of 2 pi, which is 3 times 1, or 3. So in this case, we have a tie. The 3 and the 3 are both the maximums, and this is the minimum. So there's actually a tie. So for step 4, we would say that we have an absolute minimum at pi negative 3, and we have an absolute maximum at 0, 3, and 2 pi 3. So the maximum is 3, and it exists at both 0 and 2 pi. Okay, so let's look at this one. We want to find the absolute value of absolute extrema of f of x equals secant of x on the interval from negative pi over 6 to pi over 3. So the same kind of deal. We're going to take the derivative first. Notice that none of these derivative formulas are going away. You do still need to know the derivatives. So this derivative would be secant x tangent x. And we're going to set this equal to 0. So remember that secant is 1 over cosine of x, and tangent is sine of x over cosine of x. So in order for this to be equal to 0, this is only going to happen where sine of x is equal to 0. And in that interval from negative pi over 6 to pi over 3, that means that x equals 0. That's the only place in that interval where that happens. Now f prime of x does not exist where the denominator, or cosine of x, is equal to 0. And this doesn't happen in the interval from negative pi over 6 to pi over 3, because the only places where this happens is basically at pi over 2, which is outside of this interval, and 3 pi over 2, which is also outside of this interval. So x equals 0 is the only critical number. So for step 2, I'm going to find f of 0, which is secant of 0, and that is 1 over cosine of 0, which is 1. Okay? And step 3, I'm going to find f of negative pi over 6, and you can go back to a 30, 60, 90 triangle if you want to. Pi over 6 is the 30-degree angle. So f of negative pi over 6, we know that negative pi over 6 is down here in the unit circle, so a smart trig class tells us that cosine is going to be positive, so secant is also going to be positive. So the secant of negative pi over 6 is going to be the hypotenuse over the adjacent, so that's going to be 2 over the square root of 3, or 2 root 3 over 3. And f of pi over 3 is going to be secant of pi over 3. And again, secant is positive, so this is the angle that we're looking at here. So that is going to be 2 over 1, or 2. Now, in order to compare these y values, we do kind of need to know at least an approximate value of 2 root 3 over 3. So that's about 1.15. So you can see from the 3 values that we have that the 1 would have to be the minimum, the 2 would have to be the maximum. So for step 4, we have an absolute minimum at the point 0, 1, and we have an absolute maximum at the point pi over 3, 2. So one of the extrema is an endpoint extrema and one of them is interior.